Hi, in this video, I show my work is one-story building. In this project, I use Revit and Grasshopper, and I also integrated Karamba for structure analysis. I briefly explain the steps I followed. The first is the modeling process. I created a model using Revit. The design focused on the concrete structure. I use structural column, beams, and floors. Afterward, I integrate the model into the Revit.Inside to further develop some details. I created with the structural elements, columns. For example, this is my columns 30 to 45, and these are beams, and these are my beams. I created first I duplicate and edit this elevation value, and this the floor for the created this. I made it is 1 of 1 and not a big floor. I do it with step by step. After this Grasshopper, I used this plugin Rhino.Inside and click the Rhino. I already did this, so I opened this page. Sorry for this. Firstly, I use this structural analysis plugin. In this step, I use Karamba for analyzing load and structure. This helped me understand how the forces were distributed across the structure and the overall performance, the design. Firstly, I will show these meanings. These are categories, columns, framing for the beams, and this is floors. I can show this the first group, this for the columns, because we did this because we need the element curve. We made it from the Revit, but it's a model, but we have to identify the Grasshopper, these elements. So we made it like, we made it this group. And we give a name, columns, and there's a value for the height and width evaluation, because I use the Galapagos in the end of these groups. We give a material, concrete is a C30, C37, and we can see this material point. And there's a level picker because we need the support from the foundation. For example, I will show it with section. This is the B1, and we identify to this support from these points. And there's another level picker for the load and the end of these groups. There's a merge because we have to the load assemble model. These are elements we can see, and the other thing is the shell. We can see this, so I can show it like this. And there's a load. There's a gravity. We identify this, and we merge them to this point. And this result came from the Galapagos. I use the Galapagos to minimize and this value. We start the solver. I start the solver, and I get this result. So I picked the best one. The best one was the 0.06. The Galapagos related with this. It's fixed. It's Galapagos fixed this value. There is a maximize and minimum value. I arranged them because it have to be normal value. So I did it 15 and 80. For example, floors, I made it this value minimize, minimum, and maximize is 10 to 50. After all of these groups and these things, there's a last thing, assemble model, and I bake the model. I already bake it and hide them, and I will show the result. This is the result of the Karamba structure analysis. There's a value for this structure analysis, and I can explain it like this. Firstly, I did with the Revit structure modeling. After this, I identified these elements with categories and element curves. There's a value, and Karamba also Galapagos fixed this value for the best result, and we can see the results for width and height. And the last end of this plugin, we get this value for this span and the maximum displacement, and that's it. And this is the structure modeling from the Karamba. Thank you for listening to me.